Right. Okay. Right. So today we'll start with Capsmill. Okay. So we've done. We have seen almost all the problems using Capstone till the previous class. Okay. So today we'll see the last part of this sim lab. Is the Capsmill, where we have to do the drawing, give the tools that has to be used, and other details to the software, so that it is going to perform the milling operations as per the instructions given, and the program will be generated automatically. Okay. So for that, we'll go to first problem number 1. Okay. So yes. So we'll go to this problem number 1 and that we did in milling. Okay. So again, we need the drawing over here. Then we'll have to write the coordinates table. Okay. And so here, I'll just go with the regular one, where we are going to start over here as point number 1. Okay. 2, 3, 4, and so on. Okay. For which, when we did milling problem, for this particular part, we have written the coordinates. Okay. That is what I have shown it over here. Okay. Right. So we need this to draw the diagram using Capsmill software also. Right. Yes. So now all those things that is involved over here is, the first thing is that always for um, any milling problem you have to do face milling. Okay. And then the remaining things. So in this case, after face milling, we need only the end milling tool uh, to do this milling operation. No other things are present over here. So we'll see that how to do this, how to do this using Capsmill software. Okay. So yes, just a second. Yeah. Okay. So first we'll go to Capsmill software. Okay. Right over here, out of the on the last row at the center. Okay. So double click on this. Yes, the software opens. We'll go for create new parts. And then we'll enter the workpiece material, and always make sure the units are in mm. We also have an option in inches also. We'll always go with mm. What is the workpiece material? Okay. And how do we want to set it up? Also we can do it. So we have what was shown over here. So we have 3 tabs over here. One is setup data, next one is table setup. Yes, this is table setup. How should the part be onto the workpiece table? Right. So we can also make that arrangement over here by choosing any one of the 6 options that is being given over here. And then lastly, we have the documentation tab, where we can enter the part number, name, and other things over here. Right. Okay. So we'll go to setup data tab, units in mm, workpiece material. Okay. We can choose steel or even aluminum. Right. And tool change position, where should the tool be changing? Okay. Right. So we can give the x, y, and z values. It will be usually at 100, 100, 100. Okay. So the z height is 100 mm, which is quite sufficient for the problem that we are going to do. Or else later also we can come and change it over here. So again, now after doing this, if you look at the screen, it is almost similar to that of Capstone. Okay, so we have all the zoom in, zoom out, fit, move, and other things onto the left side of the screen. And on top, we have the new file, save, open an existing file, and other options. And below that, we have the drawing tools to draw a line or a multiple line arc, different types of arc and circle, right? And other things also. So basically again here, if you look at the bottom of the screen, we have three tabs. One is the geometry, second one is the machining tab, and the third one is the tool path tab. Okay, same as that of capstone. Okay, so in geometry we'll be drawing the geometry. Okay, so save the program. I mean, kind of keep saving it in between. So you can choose multi-line option. So you have line, input line, a multi-line, you have perpendicular point or length and other options over here. And then circle to draw an arc. Then you have different ways to draw an arc: start, end, and center. Start, center, and angle. Start, end, and angle. Tangent, radius, and semicircle. So all these things, options that we have, where we need to give only that particular values. That is the starting point coordinate, center coordinate, and the ending coordinate. So like that, whatever is mentioned, you have to give only that. And then we have for circle also 2-point circle, 3-point circle, tangent, point, radius, and so on. We can also draw next one a rectangle or a square or a polygon using this particular icon over here. And then we have circular pattern. Okay, if you remember the solid edge, when you do solid parts, you have circular pattern option. Same thing is over here, where we can have uh, the same diameter of hole to be placed on a particular radius, where these holes have to be distributed equally at regular angles. So we can enter the diameter of the pitch circle, then the diameter of the hole, how many holes do we need, what should be the angle, and so on. Then yes, you can give this data. We are just showing one how this will look like, how to use this. So diameter 80, number of holes are 6, angle of the first hole. Right. So you can see here in, you look at it carefully, you can see totally 1, 2, 3, 4, 5, 6 plus marks, which are the center for each of the hole that is there. Okay, so like that it will appear. Then we have linear pattern, where you can place the hole of same diameter along a straight line, which can also be at an angle. Okay, the line can also be at an angle, and all these holes will lie in one straight line. So length of the entire line, how pitch between the holes, what is the distance, center distance between two holes, what should be the angle of that line. Yes, so you can see here. And you can give the starting point coordinate. That is what we are supposed to enter over here in the dialog box onto the right side. Yes, then is to define the contour, erase, and then next icon break and trim, then extend, insert a chamfer or fillet, right? And then, so these things that we have. The copy feature, move back and forward, right? Okay. So before going to the machining, we need the blank and other things that has to be completed in the geometry. So we'll start with we'll start drawing the part. So first one will be, we are going to give 25 comma 25 for the point number 1, 25 comma 20 35, right? Okay, and that is reason because I'll just show you here. We have point number 1 to be placed over here, but that is but we have the blank to be present out. So this is going to be 0 comma 0. This distance will be 25. This distance will be 25. Okay, and the reason why it was given 35 is that because up to here this distance is 25 from the horizontal line, and you can see here there's a radius 10. So this is another 10 mm distance. So here we have point number 1. Okay, so this height is going to be 35 and this is going to be 25 for point number 1, and you can see that same thing over here in the table also. Okay, right. So next point, we'll give the next point again. So 25 comma 55, vertically a straight line. Yes, next we'll go for 25 comma 35, starting from the other end of the line also we can go ahead. So 25 comma 55, and then next one will be 35 comma 65, an inclined line, and then 35 comma 75, a vertical line. You can just go on entering the coordinates one by one. If it is going to use only straight lines, just a second. Yes, okay. Okay, so if you go for R, start and radius, so starting point, ending point, and the radius that we are going to give. So radius is 10 mm. So we'll be getting a radius in this particular manner. So if it is okay, yes, we can go ahead. So starting point will be here 35 comma 55, then another one will be the other value that we had entered. Otherwise we'll have to interchange the starting point and the ending point coordinate. So again we'll go to arc. Okay, now the arc is going to be in the other manner. So first we'll be entering will be entering 55, 95, the other end of the arc, away from the drawings that we have done till now. Then we'll give the coordinate for the end point of the existing arc, that is 45, 85. So now you can clearly see here we have given starting point for this first arc. Here is the starting point. This is going to be the ending point. When we need an arc in this particular manner, the second one, we are going to give the starting point over here first and then joining it to the part over here, and then enter the radius 10. Now we can go to multiple lines, since later on it's going to be only straight lines. 55, 95, and there it's going to go to 85, 95. Then we are going to have an arc. Five, 95. Ending point of the arc is going to be starting point will be 95, 85. Then ending point will be 85, 95. Radius 10. We will go to the straight line 95, 35. Then radius 85, 25 to 95, 35. Radius will be 10. Draw a straight line once again. Coordinate will be 85, 25. To 35, 25. Finally draw one radius over here, 25, 35 to 35, 25, radius 10. Right? So now we'll define the contour. Just click on the fine. Entire thing should be selected. Okay. Then save as that, so that the drawing is has been saved to consider it as the milling path. Now define the blank, the raw material size. So now here we can give x, y, and z coordinates. So 120, 120. So blank thickness will give 40 mm, and that same 40 mm will give with z coordinate at the bottom should be minus 40. That means the top surface of this rectangular cube that the rectangular prism that we can see is going to be, the top surface is going to be at one corner we are going to have 0 comma 0 comma 0. As the thickness of the slab is going to increase, we are going to move downwards, right? So the blank is shown over here in bluish green color. Minus. Yes, if you put it on minus 10, yes, this is how it is going to look. You can see that the 0 comma 0, the one end of the blank is, corner of the blank is going to be minus 10 comma 10. Away from the center of the axis. Okay. Yes. Now if you go to machining tab, now here we have different set of icons that you can see here on top. For face milling, then we can click on that and we can select the tools. Okay, face milling, we have face mill with the different diameters that you can see here. After selecting that, the face milling tool, you have to click on the blank because the face milling tool is going to start outside the blank. Okay, once you click on that blank, you will get this particular window where you can enter the name of the operation, whether the process has to be rough finishing or fine. Now, then if you look over your area to be cleared, in which manner the tool should move, okay, from left to right and then again from right to left, or should it move in a contour path? And then here we'll enter what is the work surface Z value and what should be the material thickness that it has to be removed. So we'll be removing 10 mm of the material. Then return to Z at 100 mm. That is after the operation. Yes, cutting method here you can see the tool should start its cutting outside the workpiece. At what distance we can enter that over here, and we can choose the path in which it should cut. So one is in this particular manner, the other one is one way, or the other one is in a zigzag way, or even in inclined manner. We can give the angle of cutting. Then cutting parameters we can set. Depth of cut for each pass we can give, okay, we'll give 5. Then click on OK. The moment we click on OK, right, you will get this option where we'll be able to see 4 circles with an arrow mark from each, where we have to select any one of them. That is, it is going to ask from where should the tools, the face milling operations should start. Okay. So we'll select one of them. Next we'll go for end milling. Select a tool. Click on the milling path. So I've selected 5 diameter of, okay. End milling tool, finish milling using 4 flutes, 5 Then if you click on edit geometry, you can see the end milling tool, the flute length and the length from holder face. All these things can be adjusted. Always make sure that the flute length and the length of the holder face should be higher than the depth of cut the that we are going to use in the in milling. Click on OK. Click on the milling path, that is this red color, the part drawn in red color. Click on that. Yes. Now click on the point from where the milling should start. Okay. Then click on yes. And then it will ask you whether the milling tool should now pass outside this line or inside this line. Okay, we have 2 options. Okay, right, outside the line that we have drawn or inside the line. So we have to select one of the circles. So we'll select the outer one. Okay, then you'll get this particular window. Okay, where now we have to enter what is the working surface, that is the width, the depth, total depth of milling, then the milling width, okay, and other data. So work surface totally up to -10, width. So at the same time, we have the process, whether it should be rough or the bottom should also have a fine finish, or the sides should be having a finishing surface. Then cutting methods also are there. 3 options are there. So we can choose the one required. I'll show each one of them. So now we'll go to tool path and we'll see the simulation. So you can see here the end milling tool, the face milling tool. So 2 times it will do, because for every time we had given a depth of 5 mm. Next will be the end milling tool that has appeared here. So for each pass it is going in only for a particular depth. I think it's 5 mm that we gave. Then you can get this particular one, the cycle sheet and all. You can save this in the PDF format. So if you click on here, after the on the top left, we have first for new file, open a file, then save, then select a machine, then we have the fifth icon to get the cycle time sheet, which will show the amount of time required for each operation, what is the RPM used, feed rate, and all other data. And this can be saved as a PDF file. So you can see the program that has been generated automatically. So after that, we have the uh, for the program number, that is the sixth icon just beside this cycle time. Once you click on that, get this dialog box, and once you go OK, the automatic program will be generated. Tool list. Then what is the power consumption? That is this particular one icon over here. It is the spindle power that has been used. Once we click over here, we will get the feed rate and other things. So go to tool layout and see the operation in line modes. Okay. You can see operation, and you can see this blue color lines represent the path of the in which the face milling has moved. So on each place, if you click here, you can get the data, starting point, ending point, and other things. So here, once on the tool layout, you can also select which particular operation to be only simulated. You can select the different views in which the simulation to be shown. So you can see here clearly. So if you look at this particular corner, this is our 0, 0, 0, which is one of the corners on the top surface of the rectangular prism. Yes. So the yellow lines are nothing that the movement of the tool, face milling tool. The red color portion is the thickness and the shape in which the end milling has to be performed. We'll see this in a slower motion. Yes, this is the end milling that has to be performed. You can see that the face milling tool shown on white color lines landing up near the workpiece, and this particular portion over here on top for about 10 mm is what is going to be removed. Yes, that is the cutting action, the face milling tool, and returning back for the second time. So first time it was done, you can see here it has gone only for 5 mm. It has to go down once again completely, for that is for totally 10 mm. Yes, you can see that the end milling tool appearing over here, starting at point number 1. And particular depth, okay, for the uh, depth of cut in the first pass. Okay, we'll see the face milling once again. So out of this total 10 mm, only for 5 mm in the first pass. Looking at from the front view, yes, now the end milling tool appearing here and doing its operation for a particular depth, maybe 2 or 3 mm, whatever we had given in the cut. So totally 1, 2, 3, 4, 5 passes by the end milling tool. So here you can see that in pink color lines, first, second, third, fourth in the isometric view. This end milling tool, here you can see going along the contour for a particular depth. First pass, now go back to the next depth. Now again along the contour, but for a much more greater depth. the next layer. Finally, right. Okay. So this is how we are going to make use of Capsmill software. Okay. And now we'll shall go to another problem. Go to select this one. Okay. So yes. So for this particular problem, we'll have to do face milling first. Second one, end milling along this contour, and then we have to draw. We have to drill two holes of diameter 16. Okay, as shown in the diagram. Okay, right. Okay, so we'll see this particular one. Now we have only one thing. Addition is the drilling part. So we'll go to Capsmill Software. Okay, in workpiece. You can choose the required one. Save this file. We'll first draw the part. Go to multi-line. First point will be 0, 0. Second one will be as per the drawing. So we'll be starting from 25, 25. Next one 25, 75. 67, 75. Draw an arc starting point. The arc 67, 75. Ending point 75, 83. The radius 8 mm. And go to multi-line. we'll, after drawing this, we'll go to define the contour. To draw, define contour, auto contour. Click on the drawing, select yes. We'll go to define a blank, draw, define a blank. Blank size to x and y coordinates 150, 150, 200. All right. Blank thickness 30. Z coordinate minus 30. I'll go to machining tab, go for base milling, select a tool, if you click on edit geometry after selecting a tool, you can see the parameters of the nomenclature of the tool with dimensions. So select a contour, select the blank. So you can choose rough finishing and finishing operations to be performed using the same tool. Give the details. Material to be removed for 10 mm. Each pass 5 mm. Depth of cut, total depth of cut is going to be 4 mm for each pass. Then click on one of the circles. Side milling. That mentioned that we'll be using for end milling. End milling tool with 4 flutes. Select a suitable diameter 5 mm. Length let it be 80. Flute length let it be 30. Select the contour and click on one corner. Click on yes. Now whether the inner circle or outside circle. So we'll generally select the outer one. Enter the parameters. Work surface Z minus 10. Material width should be for 6 mm. Material depth for 10 mm. Go to toolpath. Okay, we still have to give a hole. So it is 2 holes placed in one straight line. So I will go for the other one. Points on. We have so many options. Points on line, equally spaced, points on line, unequally spaced, and so on. This is for circular pattern. This is not required now. Since it's 2 holes, we can also go with the other one. Okay, so distance should be 90 mm between each, and give the coordinate for one of the holes. Okay, that has to be entered over here. So 125, 50. See, but this way should be not correct. So I'll click on back or undo option. Number of holes 2, diameter 90. coordinates will be 100, 50. You can use the same thing using linear pattern also. Length will be 90, angle will be 0. Make use of that also. And we can go for unequally spaced holes on a linear line. It's not required for now for this one. I have it in a parallelogram and other options also, or like a grid, points in an arc of equally spaced. Points unequally spaced on an arc. Points from a file also we can upload customized. Okay, now we'll go to click on this, go for center drill, new tool, center drill type A, go to diameter tip of 4 mm, click on these points, click on done, then OK, then it will ask us for the work surface value, that is the Z value minus 10, that up to a depth of 1 mm, and then go for drilling, new tool, drill, insert twist drill, as per the diameter given, we have to select a bit of that particular diameter. So 16 mm will choose over here, and click on OK, and give the dimensions. It should be drilled up to minus 10 mm. Work surface starting from there. Hole depth should be for 30. Right. And no other parameters, it's okay. Return to Z after that should be for 20. This is about the workpiece surface. Select the machine. Now go to tool path. Simulate it. You can see the face milling being done. First pass. Then this is the second pass, and finally finishing face mill. Yes. The end milling tool appearing over here, following along the contour. First part, second, third pass, so yes, this is the center drill that is appearing, and now coming up is the twist drill to make a hole. sheet, the required, extend those data and this PDI. So see the general program. Okay. Okay, so this is about the Capsmill software. We have seen face milling, end milling, and drilling. We'll see few more in the next class. Okay, how to use the counter boring operation and other things using Capsmill, right? Right. Okay. Yes. Answer attendance. Nihar.
Yes, sir.
Okay. Nilesh.
Present, sir.
Nirab.
Present, sir.
Nirab.
Present, sir.
Okay. Pradul Patel.
Present, sir.
Bhat.
Present, sir.
Yes. Prince Tagore.
Present, sir. Present, sir. Present.
Okay. Rishabh Pandey. Okay. Rohan Kadam.
Present, sir. Present, sir. Sir, Rohan present.
Then Roshan.
Yes, sir. Present.
Roshan.
Yes, sir. Yes, sir. Present.
Okay. Suman Sagar.
Yes, sir. Present.
Okay. Suman Sagar.
Sir, present.
Okay. Sagar GV.
Present, sir.
Yeah. Okay. Subramanya.
Present, sir.
Okay. Sumok.
Yes, sir.
Right. Okay. Only these many people have logged in.
So Rishabh is also present.
Okay.
He has